Hi, my name is Heather, and I'm a software engineering major.
I'm Michelle Lamont.
And I am Timothy Steele, and this is our presentation about pseudocode design.
Pseudocode is a design tool to allow for high-level problem solving without being slowed down by syntax or compiling. Pseudocode falls between spoken structure and syntactic structure in detail. There is no required syntax for pseudocode, but there are keywords. The keywords can move problem solving into design decisions. You can see here there are several examples of pseudocode. The first three examples are tailored to specific programming languages, and the last one is a general pseudocode example. Now let's review some keywords. Pseudocode keywords help make clear what each line is doing. At the top left, read and get are keywords we use when talking about a computer receiving information from input sources such as a keyboard, mouse, a network, or a sensor. Moving to the right, print, write, put, and prompt are keywords associated with sending information. At the bottom left is a list of built-in operators, and to its right are the keywords for assigning value. On the left of the screen now are the keywords if, else, switch, and case. These keywords are for comparing two values and selecting alternate actions. On the right at the top are the keywords while and for, which indicate repeating actions. Under that are declaring and calling, which outline the pseudocode conventions for declaring and calling functions.
Using pseudocode has several advantages. First, it's easy to create and modify, especially because it uses more natural language. This language is less precise and mechanical, allowing us to use programming terminology yet be less specific. This allows non-programmers to review proposed code, and it makes it an especially helpful tool for brainstorming about an algorithm. When you approach an algorithm, there's several ways that you could accomplish the same task. And by writing out specific pseudocode, it allows you to examine different options. It is also helpful for identifying the structure of an algorithm or function. When you see pseudocode, you can see that structure without being distracted by the syntax details. It allows you to focus on those details, but still maintain a focus on design. This allows for clarifying algorithms, especially on a team where people are making decisions about how to accomplish something. It helps to get everyone on the same page. This pseudocode can then be a reference for programmers when coding.
There are a few disadvantages of pseudocode to consider. Pseudocode does not have an accepted standard, so pseudocode keywords may vary from creator to creator. One creator's logic instructions may not seem as logical to the next. Also, from the viewpoint of a programmer, pseudocode is non-specific to a coding language. However, this could also be considered an advantage. Since pseudocode is implicit, finding the right trade-off between readability and precision can be tricky. Another disadvantage of pseudocode over other design tools may be the inability to show logic flow or the bigger picture. During design, it is important to remember that pseudocode is just one design tool. As with many creations, a combination of other tools may produce more clarity. For example, using pseudocode in conjunction with a flowchart negates some of the disadvantages, including big picture representation and logic flow. Using a simple example most of us will recognize, here is a sandwich making pseudocode applied to a flowchart. This design is to guide the creation of a peanut butter and jelly sandwich. Some of the pseudocode keyword indicators here include begin, get, open, put, and set. A while loop is implied in a process box, which states, "Y slice does not have peanut butter, spread peanut butter." The pseudocode written this way will clue to the programmer this is a binary process. Prompt includes get bread, to repeat, or in the making sandwich process, which is Boolean representation.
So how can we use pseudocode for Hack? Without considering all of the complex details of the Hack system, let's consider an algorithm for adding a task to a hypothetical assignment. First, I'll write add task along with a parameter to this function, an assignment ID. This allows us to make an addition to this assignment. Notice a similarity to programming syntax in the function header line. We also will put the assignment title or display it, and then prompt for input regarding task content, and we will get that input. Again, notice how these pseudocode keywords are used without specific syntax. This pseudocode could be used for a Java application or a web application in JavaScript. It's flexible. We will then write the task content to the database associated with the assignment ID.
I wanted to step in on this slide and talk a little bit about how I think this team and Hack could benefit from pseudocode. Since we aren't actually building this application in this class, we might never get to the point of needing pseudocode, but I think it illustrates a good use of pseudocode. In our team leads meetings, it's become clear that it's very hard to keep 20 people on the same page about decisions being made about the application, its functionality, and design. In weeks 8 and 9, it became even more apparent to the team leads how much achieving a single understanding in a group of people is harder to accomplish than we expected. There have been various diagrams passed around in an effort to get us all in complete agreement. If we were to move forward into implementation, I imagine the same difficulty and design clarity may come up on a smaller scale. I think this is the kind of problem pseudocode would solve brilliantly. If there's a particular method, function, or algorithm needing to be designed, putting it on paper in very clear pseudocode would leave very little room for misunderstanding. I think the teams and Hack would benefit tremendously.